Remote automation is a trend not new to technologies, and it all started with one simple device, a remote. The appliance we will be discussing is a simple infrared remote. The IR remote works on an infrared IR sensor which manipulates the infrared region of the wide electromagnetic spectrum. So, how do these infrared remotes work? Well, they have two parts, an IR transmitter and a microprocessor. So, what are these IR transmitters? Well, an IR transmitter or an IR emitter is a source of light energy in the infrared spectrum. It is a light emitting diode that is used in order to transmit infrared signals from a remote control in the range 900 to 950 nanometers. So now, what is there at the receiving end? Well, at the receiving end, we have these IR detectors. These IR detectors are basically little microchips installed in our television sets with a photocell that are tuned to listen to infrared light. They are designated to detect IR rays of frequency 38 kHz to avoid disturbance caused by other IR sources such as lamps, CFL, and sunlight. Now, as we can see, the IR LED gives out a signal of 38 kHz in response to which the IR detector changes its voltage to 0 volts from 5 volts. Now coming to the explicit working of the IR remote. We give commands to the IR transmitter by pressing the buttons on the remote. Pressing a button generates a binary signal with the help of the microprocessor, which is forwarded to the IR LED, which then generates an infrared wave signal. This binary signal also has the address of the television set. Therefore, the IR LED's infrared signal is received by the IR detector and converted into binary signals again, which is then interpreted by the TV's microprocessor into the corresponding action. This loops on till the button is pressed. When we unpress the button, the signal stops and hence the TV stops taking any action. Now we will demonstrate to you a simple experiment on the working of the IR remote. So this is the IR remote with the IR LED, and this is the IR detector setup connected to a power source. And this is the DSO where we see the 5 voltage source. So now, when we press the button, that is the down button on the remote, we see this excitation on the DSO. The peaks corresponds to the 0 and the valleys corresponds to 1. So therefore, we have this excitation signal given out by the IR detector. Now when we press the volume down button, what we get is another excitation signal on the DSO, which is different from the earlier one. This one too has peaks and valleys. Therefore, corresponding to each and every button on the remote, we have a different binary signal which gives out a different wave, and therefore the IR detector gives out the corresponding binary signal. So we get different binary signals for different buttons on the remote. Now coming to the advantages and applications of IR communication. Infrared communication is a very cheap and power efficient technology, and hence is preferred over other wireless communications like RF transmission and Bluetooth. It is in fact used in automation, in robotics, projectors, televisions, multimedia sets, and other devices like DVD sets. Thank you.